Hello everyone and welcome to part 3 of 3 in our mini-series on malt with Dan and Jamie from the iconic Simpsons. I'm kind of sad we're coming to a conclusion. These episodes have been really well received and I personally have really enjoyed listening back to them, as long as I fast forward the parts where I don't have to hear my horrible voice. In the conclusive episode, we tie the rich tapestry of malted barley into what we receive as the brewer and what effects it does and doesn't have in the brewery. We all get certificates of analysis, but do we understand them? How many parameters do you look at? 1, 3, 5? And if so, do you know why you choose these and don't choose the others? You'll be able to answer all these questions with confidence by the end of this episode, but that is of course assuming you've already listened to part 1 and 2 of this mini-series, as you can't really understand a COA if you don't understand barley and malting. So this is your chance to pause, go back, and listen to part 1 and 2 now. Right, here we go. Let's get straight into the final part of the mini-series on malt with Jamie Ramshaw and Dan Cooper. Okay, so in this section, I think we just want to talk more about the certificate of analysis itself, parameters on it, and how it kind of impacts the brewer, the brew house, and what they're getting in. So it will be really interesting to talk about just high level the standards of malt analysis, because there's the IOB, ASBC and the EBC, is that correct? And how do they differ massively between analysis, and if you're getting malt from Germany or America, is it comparable between British malt?
I'll hand that over to you, Dan.
It's easier, I think, to compare EBC and IOB. I'm not so conversant on ASBC. I've sort of, looked into it a little bit, but sort of most of the malt analysis is, I would say, divided into kind of like the malt analysis you do on a liquid derived from the malt, and then another set of analysis that's derived from the dry malt.
Mm-hmm.
So things like friability, it would be done on the dried malt, but stuff like beta-glucan, free amino nitrogen, colour is done on a liquid extract, so a wort of that malt. And I think the key difference between EBC and IOB is the mashing method that we use to derive the wort. So if we were going to say TN, there are different ways of analysing TN, but it's TN. It's just total nitrogen, it's done on the dry malt. But when we're talking about the wort that we produce, so colour, EBC, colour, beta-glucans, it's the mashing method that can impact that. So EBC, IOB, you've got very distinctly different mashing methods. So with IOB, it's a single temperature mash. So you mash in at 65, and it's held at 65 for the duration of the mash. For EBC, it's mashed in at 45. There's a hold step at 45. Then you heat it up to 70 degrees, and there's a hold step at 70 degrees. So you've got a kind of like a single temperature infusion mash, and then a kind of like a temperature programmed mash for the EBC, and that gives rise to slight differences. So, for example, if you're looking at something that's analysed for EBC, and you're looking at TSN, and your callback index, for example, callback index is effectively SNR, but it's the EBC version of SNR. Your callback index will be different from your SNR because you're mashing at 45, so you've got a proteolytic stand, and so you'll get more soluble nitrogen, and that affects your soluble nitrogen ratio, your callback index. You'll also get a different colour because you've got more soluble nitrogen.
Mm-hmm.
So the analytical methods will have an impact on the analysis that you're getting, and there will be some subtle differences, as I say, different colour result, different SNR, callback index, TSN, fan, because of that mashing method.
So it does vary quite a lot.
It can. You can sort of, if all of a sudden, sort of you've been used to a C of A that's kind of been analysed against the IOB methods, and you then move to a brewery where their specification is in EBC, you might suddenly be panicked by the fact that colours are looking a little bit different, the callback index is looking a bit different. So it can sort of give you a different idea of what what you're going to get.
So when we speak to new customers, especially on darker malts, they'll tell you what colour they want in their crystal medium, but then you've got to go back and ask, is that IOB or EBC? Because they don't probably know a lot of the time.
And then
there's old money.
But then there's a difficulty within colour. Colour's even worse in some respects, because you've got a 450 gram mash and a 550 mil mash, and that then gives you different sort of colour analysis. So I suppose in some respects the malt analysis that we do would be made so much easier if we just had one system that we could analyse against. So forget about ASBC, forget about EBC, forget about IOB, just have one method of analysis that's globally is a standard, and that would make everything nice. Life a lot easier.
So what parameters should brewers look at on a COA to let them understand how much extract they're going to get? What are the best parameters and how are they sort of measured?
Extract.
That was an easy one. Next.
There's a clue in the title. It's extract, but that is going to tell you what you're going to get.
But how is it conducted? Like, how do you measure that in the lab, and does that translate to a brewer?
Well, I think what it's saying is this is the most extract you can get in lab conditions.
Mm-hmm.
Yeah.
And then your brewery will be, say, running at 88% extract or percent extract, or it might be lower, or it might be higher, and you're running off that extract you're getting from the C of A. But so you should still be hitting your percentage, and then you can work within your brewery to try and increase that or not. Because sometimes that extract, because it's been done in the lab, and I presume the grist has been milled pretty tight, hasn't it? It's pretty fine mill.
Well, I mean, this again, it sort of comes down to you can mill it to a different grist size. So, within the laboratory, we will have a disc mill that we can change the grist size. So typically for IOB analysis, we will provide you with what we call a 0.7 grind. But you can do a 0.2 or you can do a 1. So 0.2 mil or 1 mil grind. So you can go from a very fine to a coarse to an even coarser grist, and you can get things like fine coarse difference. So you do your mash on a 0.2, and you do a mash on your 0.7. You take the wort, you measure the specific gravity, that gives you your extract, and then you can see the difference. So the finer grind, you'll have a higher extract. The coarser grind, you'll have a lower extract, and the fine coarse difference is the difference between the two. But what some brewers would like to see, some distillers, is they would like to see those two numbers close together, because it gives an indication that it doesn't matter, as long as they can grind consistently, they'll still be able to achieve the maximum extract. Because there's always a balance, especially with a lauter tun or a mash tun, is not over grinding it. So if you want to achieve your maximum extract, hammer mill and a mash filter will give you the maximum extract, because you're grinding the malt to a fine powder, and that's allowing maximum extraction of the available extract. But for a brewer who's got a roller mill, if they want to achieve more extract, they can bring their mill setting tighter, but then that potentially gives them issues in terms of runoff and all the rest of it. So what a brewer would like to see is that number, that fine coarse difference, as a small number, because it means that they can go a little bit coarser and still achieve a high extract.
But when you get the difference and you get poor extract on the wider grind, that's often down to poor modification. It's poor homogeneity. You've already got like dead grains in there, a lot of distal ends, unmodified distal ends. And that's a germination fault, isn't it? That's a lack of homogeneity in germination, steeping.
Yeah, I mean, questioningly. I mean, these, and I suppose you sort of, from a maltster's perspective, when we look at the analysis that we get that will eventually fall onto your C of A, there are certain key parameters that we will look at, which will give us the indication of how well we've done our job as maltsters. Extract is one of those. We're obviously looking to maximise the extract, because that's what you're partly paying for. But we'll be looking at things like S&R because that gives us an indication of the modification, the protein modification. So again, we're looking that, there's I suppose a window of opportunity where the S&R's just right. It's kind of that Goldilocks zone. Is it too high or too low? We're looking for it to be in a certain area. It gives us the sort of the knowledge that we've got the modification at the right point. So, and then you look at things like beta-glucan, and for me, it's all an indication of how well we've broken down that grain. Mm-hmm. So, if you look at what we've done during the malting process, what we're trying to do is break down the cell walls, because to be able to break down the cell walls, it reduces the potential filtration issues that you'll have in the brew house. But we also want to break down the cell walls so that we can allow the enzymes to get to the starch. But we also then need to break down the protein matrix that's within that cell, because the starch granules are embedded in the protein matrix. So we break down the cell wall, we break down the protein matrix, and then we know that we've liberated the starch so that you can take it out when you're mashing. And the three bits of analysis that we look at to see that we've done that correctly is beta-glucan, because that's the cell walls, S&R, because that's the protein matrix, and the extract, because that's mm-hmm. the starch. So, as a maltster, I guess as a brewer, I would be looking at those three parameters and sort of saying, okay, that gives me an idea of has the maltster done a good job. So if the extract is high, the S&R is within that kind of 38 to 42 window, and the beta-glucans is less than 100, then, yep, it's a tick in the box that we've done our job correctly. The other part of it, which is a useful piece of analysis, is friability. And friability links in with all of those, because when you are breaking down the endosperm, you're basically softening the character of the grain, so you're making it easier to mill, make it easier to break down, make it more friable. So the friable links in with level of extract, level of S&R, level of beta-glucans, because if you get a high friability, you've broken down the cell, the endosperm well, because it's more easy to it's more friable, it's more easy to mill. If you get a low friability, it's an indication that you haven't broken down that endosperm very well. So for me, when I'm looking at a malt CoA, I'm looking at extract, S&R, beta-glucan, and friability, and they give me most of the clues as to whether we've done our job correctly as a maltster.
Yeah, it's really interesting, because is it possible to have an extract of 300 and 300 on 2 CoA, but higher levels of beta-glucan and like lower levels? Does that mean it's easier to extract that amount of sugar in the brew house? Is that kind of, I'm trying to think from a practical point of view, if I'm a brewer looking at two sheets and they're the same extract.
I know what you mean. If you've got the same extract, but you could look and see which one you're actually going to do better
exactly.
with. Yeah,
which one?
By looking at the ones more evenly modified.
Yes.
You've got a better S&R, you've got a better friability. Going on, I mean, you worked in a big brewery and took in bulk loads of malt, but did you do any intake tests on it when it came to?
No.
You see, a lot of, I worked in a big family regional, we would test the friability and the homogeneity before we accepted it, to make sure it was properly modified. Because it was something we could do very, very quickly. And if you didn't hit the spec, we could send it away.
Yeah.
Unfortunately, most brewers can't do that, but when you're at a certain size, you'll do quick checks to say, is it what we asked for? And that is a really good check to make sure it's going to work.
Because the friability test's really easy, right?
Yeah, you just put it in a mill when you weigh how much the fractions.
Mm-hmm. Yeah. I mean, the friabilimeter is it's a specific piece of equipment. It works in a similar way to kind of like a mill, but it gives you an indication of how well modified the malt is.
Because that's what you're looking for more than the extract, really, is how well modified it is.
Because you can get at it, yeah. Because your brewery will work differently to anybody else's brewery, so it's really down to what works for you. As we said, I mean, a big hammer mill, you can send anything in there, a mash filter, but there'll be certain breweries that need it to be modified to a certain extent.
Yeah. And then this comes down to sort of like James' point earlier about sort of, we will give you an extract figure, and then your sort of yield against that will be sort of 88, 90% or whatever. But that's because we are in the lab, sort of not giving it the ideal conditions, but giving close to sort of ideal conditions. So we're milling it to a point where you wouldn't want to be milling it in the brew house. So we're milling it quite fine. 0.7 mil setting on a mill is a very tight mill setting. So, we are able, because of the method that we're using, to get the extract out. One other thing to kind of mention is that sort of like the grist to liquor ratio that we use in the laboratory is significantly different from what you would be using in the brew house. So the grist to liquor ratio, I think, is about sort of 1 to 6.5, 1 to 7, whereas in the brew house you're probably down at sort of 1 to 3.
That's 2.5.
1 to
2.5 is
so completely different. So we've got a very, very sort of like very thin mash, quick to filter because it is a thin mash, and we're able to then get the extract out more easily.
So I don't want to what's the word I'm looking for? I don't want to compartmentalize what you're saying, but is it more prudent for a brewer to be looking for how well the grain's modified rather than looking at that extract value is?
No, you're using the extract to judge that extract against what you're achieving.
Mm-hmm.
But if you're not achieving what you normally would achieve,
Yes.
then you can then look at the other parts to say, well, it's probably down to these particular parameters.
Mm-hmm.
I think it's looking at it as a holistic piece of, it's about the story of the malt. And as I said, there's those key bits, the key analytical parameters that we were talking about earlier, sort of extract, SNR, beta-glucan, friability. That gives you the story of how that malt's being processed.
Yeah.
You've got the extract figure. If you're not achieving that extract figure, as Jamie says, you then go through those other parameters and say to yourself, okay, I can sort of see perhaps why I'm not achieving it, because it's a little bit less modified compared to the previous batch of malt I was processing. Maybe I need to do something different in the brew house to be able to manage that.
Yeah.
Mm-hmm.
So,
unfortunately, on the scale of a lot of brewers, though, there's not a great deal you can actually do to change that. I mean, your temperatures are quite hard to hit if you're thinking about 0.5 degrees C in mash tums.
I suppose one of the things, but again, it's very difficult. If you're sort of seeing a drop off an extract, one of the key things you look at your mill settings, and if you've got a mill and play around with those.
Mill settings was the biggest thing for getting extract.
Yeah, helps a lot, isn't it? It's quite an easy fix as well.
It is. Just keeping the husk as big as possible at the same time.
Yeah, it's really interesting. I think we did some analysis at Brewery I worked at, and we found that the extracts were pretty similar across the malt, but when we had varying factors I was especially looking at beta-glucan, whenever we were having quite varied levels of beta-glucan, the higher it was, we almost saw a drop in efficiency, even though we were doing things, not everything exactly the same, but similar, and we could see that we were, we'd lose 2% or...
And that was access of water to the starch, and the enzymes getting to the starch. That's what's causing it.
Yeah, and it's really interesting actually that I think so often brewers look at the extract and think, I've got more extract in that's better, but actually it's how achievable that extract is to get out is equally important as you said, looking after those key parameters. What about if you're a brewer looking at a COA and you're kind of looking for those healthy fermentation characteristics on a COA? What are they looking for?
Well, you're looking for amino acids generally.
So your fan is free amino nitrogen. So, I mean, I sort of tend to sort of think of a level of sort of 1.25 mg per litre of fan. If it's above that, I mean, 1.25 is a little bit on the low side, but I've known of fermentations get stuck below 1.25. So I think the lower you get, the more challenging it becomes to have that healthy fermentation. But I think sort of 130, 135 is generally a sort of like a reasonable level to have fan. If it's higher, it's a bit better. But
I can add to this because of some work I did where it relates to diacetyl. There's two things as well. If you've got a 125 but you're adding a lot of adjunct, and there's a lot of people who are putting a lot of adjuncts in, you're not getting that fan. So I think nowadays you want higher fan if you're putting more adjunct in than a 125. But also, we found that if the fan, brewing a big lager, if the fan went below, say, 150 with a bit of adjunct, we had terrible diacetyl problems at the end of fermentation, the control of diacetyl, because it's when it runs out of fan, it starts producing diacetyl. So it was about how high the spike was to start off with, and then how quickly you could remove it. And what we found is the spike was too high. It wasn't how quickly we were turning it back into acetylene. We were just producing far too much. And I looked at every single parameter created charts and just looking for relationships, and I just couldn't find it. And then the chap from I asked the maltster, asked the expert, and he says, "Oh, it's that." I was like, "Oh, there you go then." So we set a target, and immediately every fermentation could go on chilled in 7 days. It just stopped like that, and we never had that parameter.
How often do you produce malt that's lower than 140, whatever, 125? I mean, you said 125, but that's
it does
like...
happen now and again.
I would say the big challenge with fan is that the lower colour you go.
Yes.
Because the problem that you have is that to achieve the lower colour, we need to hold back on the protein modification. So we've got less soluble nitrogen, and then you have less free amino nitrogen. So the challenge for us, and when you were sort of saying a bit earlier about, are low colours challenging to make? Yes, they are, because there are a number of parameters that we need to kind of juggle to get right to be able to give you the malt that you need. So the big challenge for me is, certainly with fan, is if you've got low colour, trying to achieve a fan spec is a bit of a challenge, because how do you achieve that fan with trying to hold back on the protein modification?
Yeah.
Yeah,
I think we've touched on that a few times, really, haven't we? In the earlier part, we did.
Yeah.
The fact that a spec from a customer might not actually be achievable. They're wanting one that means you need to over modify it, but they want another thing that means you have to under modify it, and it's an impossibility to actually achieve the product they're after.
So, reductionist, that was the word I was looking for earlier. Damn it. I don't know.
It's a good job you didn't use it, because I wouldn't have understood what it meant.
They were just sat and looked blankly at you.
Or I thought, oh, that's a big word. I'm sure I do know what it means. I just have to have a think about it.
So if people are looking for lower colour, are they sacrificing modification, or is it, what are the parameters are they sort of sacrificing if they're looking for the low colour? Because as you said earlier, that in the other part, that is definitely a trend, the low colour malts.
It needs to be, well, again, it needs to be under modified, and kilned at a cooler temperature, possibly over a longer period of time, or you put less grain in the kiln, so it's a more shallow depth.
Yeah.
That last one adds cost, and kilning for longer adds cost, because malting is generally designed to steep every day and kiln every day, so you're constantly filling and emptying, because you can't turn the maltings up or turn it down. It runs at one pace, and then you just have to have lots of storage to take out the bumps.
So is there anything that a brewer can look at on a COA that would help them understand the flavour impact of the malt that they're receiving in for their beer?
The variety.
The variety,
Yes.
Yeah,
Maris
so Maris, and Golden Promise.
Yeah.
Especially in unprocessed bits. So I'd say that Maris is perceived as being more malty, and Golden Promise is perceived as being more bready. That's the way I'd say it. Whereas a big modern spring variety, I don't think that's going to bring much to the party. The only part of that's going to come from colour.
Yeah.
Or fan and diastole.
Yes.
Yeah, but that's kind of different.
Yeah, so the fan and diastole. I mean, also, we talked about colour, but colour must have some sort of flavour impact. So if you're looking for the low colour, is that going to reduce the amount of, let's say, perceived malt flavour in your beer?
Yes, it will. Yeah.
Yeah.
But then of course you start worrying about DMS.
Yes. Yeah. So DMS is the problem, because one of the key areas where we reduce the level of DMS, or SMM, DMSP in the malt is through kilning, and we're not aggressively kilning a low coloured malt. So by definition, you're not going to be able to reduce the SMM down to the level that you would perhaps be looking at. But that then gives rise to the idea of, are the SMM levels actually right? So I know that some
we had a conversation about this, about DMS.
Yeah, so some brewers will have a specification for which is quite low, which is very, very difficult to achieve on a low colour malt. And actually at that level, you're not really going to be able to perceive the SMM anyway.
They're not having problems with DMS. So the conversation we kind of had historically was, there are some very large multinationals who like DMS in their beer, but the spec for SMM is around 10 up to 12. You know, we're being asked not to go above 2.5.
Yeah.
And it's like saying, I think SMM, the number that low is I don't think it's correct.
Yeah, so it's not.
I don't think I think you can get away with a lot more than that.
So the brewers who are looking to have, because there are brewers who want
Yeah,
DMS
yeah.
in their beer, that's a
Yeah.
flavour characteristic. They're
But
looking for
you
malt
need it
above 10.
ridiculously high, yeah.
Really?
They do. Yeah.
That's so interesting.
And if
Yeah.
they don't, then they won't get it. And half the DMS is off the boil anyway. Depends what you.
Yeah.
how you
Yeah,
boil it.
that's the.
You know, you could boil it all off. You could probably put a 9
Yeah.
SMM and then.
But you're saying that to achieve a SMM of 10 to 12 in a malt is bloody challenging as well. You know, because of the kilning step. You know, because
Yeah.
the kilning just removes it. But there's that sort of issue between achieving a high spec for SMM or a low spec for SMM. It's all in the kilning and how we do it. And yeah, achieving either ends of the spectrum is a challenge because you know, you're trying to sort of crack a nut with a sledgehammer. It's you know, a kiln is not a precision instrument, and so it's very difficult to control that.
Have you drunk many beers and picked up DMS where it shouldn't be?
A few, but not loads.
Well, okay. You're not going to tell us the brand, but
Certainly not.
no,
No.
okay.
Why do you?
No, I don't. Maybe I don't pick it up. But normally, if it's there, it's in a brand where it's supposed to be.
Mm.
Yeah, I can tell with one brand. But
Yeah, some of them are very like, whoa.
Yeah.
One that kind of ties into healthy fermentation and flavour, I guess, is diastatic power. So the amount of diastatic power the malt has. What parameters are coming on, and is there an impact on requesting low colour, high colour malt, and how that affects that?
Yeah, well, again, I mean, sort of diastatic power, you're looking at the enzymes that are converting your starch into fermentable sugars, that then sort of the control and the vigour of your fermentation. And again, yeah, there's challenges associated with that because, you know, certain brewers would be looking to have a max and a min for your diastatic power. The trouble is then with very low colour malts is keeping the diastatic power at the maximum end, because the diastatic power will be affected by the level of kilning that you subject the malt to. So the higher amount of kilning, it denatures the enzymes, you got the lower DP. So what you find with a lower colour malt is, say, a spec for DP would be 45 to 80. We would be seeing the DP at the higher end, you know, sort of 70 to 80, sometimes slightly higher than that. And that then will change your fermentation profile. So often have the sort of the comment with low colour malts, we can't hold the fermentation back. It's really, they're overly, you know, they're over attenuating their beers because the fermentation profile changes because the DP is higher because they've got a low colour malt. So and this is where, you know, all of the parameters sort of, you know, if you know and understand the C of A, you can then read how that will then process in your brewery because DP, you know that it's going to, a high DP is going to be likely to be fully attenuated beer as long
So
as
if
you
your
mash it in
DP
a
is
certain way.
high at the top end of the spec, you mash in slightly warmer,
Yeah.
Mm.
and you can react.
Yeah.
Or you can shorten your mash stand. You can do that.
Yeah. Yeah.
I know a lot of people don't think you do.
Yeah, it's like
You
just
can
put it
do
in for
that.
60 minutes, and
Yeah,
it's
yeah,
always
yeah.
it's
Or
always the
longer,
case.
I've heard of longer as well.
Yeah.
But that's where it's sort of like, you know, we said earlier, you know, sort of there are brewers that will sort of file away the C of A, and then there's some people that will, you know, fully look at the C of A,
Yeah.
and those are, I'm hoping those are the sort of the clues they're getting from the C of A is, okay, my DP is a little bit higher this week or this month. What decisions am I going to make in the brew house in terms of mash stands, mash temperatures, to sort of like make sure that I keep you know,
Keep the
my brew
fermentation
consistent.
under control, yeah.
And those are the sorts of clues that you pick up from reading the C of A correctly.
Yes, and understanding that everything links together. I think
Yeah.
that's I think common for a brewer to look at a COA and look at it as individual sets of analysis and wondering why things aren't in spec, and then asking for something to be, as you said earlier, asking for something to be lower, not understanding the ramifications down the COA.
Yeah. So some years I think we've run modification at the lower end deliberately because of colour, the problems with colour. Just because that year's barley meant you kind of had to do that. And sometimes you have to go out to a customer and say, your spec, we're not going to be able to hit that spec with this year's barley. And the specs will change. So sometimes you can put a concession on the spec for the whole year saying, this year's barley will not produce what you want, so let's change this one parameter for the year.
Yeah.
Under a single concession and say, we're going to let that ride. We'll do a few brews, we'll say do 4 loads. These are fairly big breweries. Then I'll have a look at it and say, okay, it's working where you've set the mould, let's change the spec for the year.
Mm-hmm.
And then at the end of the year, you go back to the original spec and start again with the next barley coming in.
I mean, a good example is nitrogen, total nitrogen. If you've got a high nitrogen year, it's going to affect certain parameters. So you can say, right, if we've got a high nitrogen year, we're going to perhaps have to look at a concession on extract, your soluble nitrogen, potentially your colour, friability, because those are all potentially impacted by total nitrogen. So I think a few years ago, 2018, I think was a particularly high year for protein or nitrogen. You as the maltster would then be having those conversations with your customers, your brewers, and saying, look, we need to be considering these parameters because this is the indication that we're getting from the crop and from our malt analysis. We need to have a discussion about whether we're able to hit your specification as it currently stands.
Exactly, and by actually hitting what we think is the best analysis for it, not the original spec for that year, we can actually maintain the quality of the malt you're getting.
Mm-hmm.
And it'll actually perform in the same way, but the numbers are different, purely for that particular year's barley.
Yeah. Yeah. And that helps. We're maintaining the quality of our malt, which helps to maintain the quality of your beer.
Yeah. So we talked earlier on about colour, and we keep saying everyone's looking after low colour malt, and the colour that you're measuring, how does that translate into the brew house or final product maybe?
Well, we touched on this earlier, where the colour that you see, so the visual colour number that is on your C of A is based on an unboiled wort. So we mash it at 65, and then we take it, we filter it, and then we measure the colour. But you will then take that and you'll boil it, and you'll add some hops, and that boiling step will generate further colour. So the visual colour in itself doesn't give you the full picture in terms of the colour. Now, the additional step, and I won't get any fans in the lab for saying it, but the additional step is a boiled wort colour. And we do have a test where we can do a boiled wort colour, and that gives you a better sort of understanding of the likely colour that you will get in your wort once you've done the boil. And generally what you see is a rough rule of thumb that if you've got a visual colour, there's about a 1.5 colour units increase for the KZ or the boiled wort colour. So if you've got a visual colour of about 3.5, you would expect a boiled wort colour to be around about 5.
Mm-hmm. Yeah, that's interesting. I think when I used to build recipe sheets and so I used to have like a coefficient for what it would look like after the boil, because obviously the boiling was
you had a factor that you
like a factor, but that was a static factor, not.
But it would have been very specific to your brewery as well.
Exactly. Yes.
Every brewery would do something different.
Yeah, exactly. That's where it's. But it would. Is that something that in the future would be useful to have onto a COA, like a boiled
Some
wort?
customers do. Some customers have boiled wort as part of their specification. So for some customers we will do that analysis, and now we'll probably get a flood of people saying,
I think you're grossly misunderstanding how few people listen to this.
Well, we might get 2.
Yeah.
But I can see the live manager now saying that's too many.
Yeah.
But yeah, I mean, it's already something that we do. It's already something that we do for certain customers who request it, and it's a useful piece of information to have, because it gives you that additional piece of information in terms of that step from your wort to your boiled wort, in terms of the step up in colour that you could expect.
Well, one thing I wanted to ask about malt COAs is how representative is the COA for, let's even go down to like the 25 kilo bag or the 1 ton bag that I have in my brewery. How representative is it? Because we talked earlier, 6 billion grains going into one germination, and then that's then got to be kilned. Kilns probably don't kiln perfectly evenly. And how does that all translate into what they're getting, and how relevant is it to to that sack or that 1 ton bag that
It's
Brewer's
totally
getting.
100% accurate.
Yes,
down
it
to the
is.
last grain.
Yeah.
You could analyse it
Yeah.
time after time, and it would give you the same answer. No.
I think one thing to say is, and again, coming from brewing into malt, is you forget that in brewing, liquids mix very, very
That is
easily.
so true. Yeah.
So you put 2 liquids together, give them a stir, and it's all the same.
Yeah.
Grain does not do that, and I think that's a very important thing. Yeah. So we do the best we can.
Yeah,
with what we've
totally.
got.
It's just, I'm thinking it from how invested people sometimes get into COAs and how relevant that investment is, because, as you said, there's so many different there's mixing, there's, I guess you've got different batches going into different, or lots going into different batches.
You could break it down into steps.
Yeah.
So if you sort of think, we have got 116 tonnes of barley that goes into production at our GKVs down here at Tivishall, and that will give us around about 95 tonnes of malt. We will take that malt off kiln, and we will have an auto sampler, trickle sampler, that will, as best we can, take a representative sample of that malt. But what the auto sampler will give us is maybe a 10 kilo sample of that 95 tonne batch. So as much as we can, we make it as representative of the batch that we have produced. So we will then analyse that, and that will give us the malt analysis for that particular batch. It's very rare that we will send a single batch to a customer, because the specifications are so, in some respects, quite tight, that one batch coming off kiln wouldn't always meet that specification.
Mm-hmm.
So we would, not always, but quite often, we will blend batches together to achieve a customer specification.
Similar to brewing.
Yeah, with blend limits as well, so you can't put anything that's so far outside of that.
Yeah.
There are limits on that.
Yeah. So, again, as Jamie says, we're trying to blend as much as possible, very, very tight within that specification. So you've got an individual batch, you're then blending 2, 3, 4 batches together, and the C of A is a calculated blend analysis from the original off-kiln analysis. So if you were blending 2 batches together, you've got 2 off-kiln analysis, you would do a mathematical calculation to get the blend analysis that goes on your C of A.
And I'm presuming, as you've worked in many maltings, that's done at every maltings you've ever worked at.
It's done at every maltings that I've worked at, yes. So it's a calculated blend from the original off-kiln batch analysis. And as Jamie said, we will then blend that as best we can. And I think we do a pretty good job of it. We will blend it from the original silos that the malt batch is stored in into an outloading bin. So it will go along conveyors, elevators, and there will be mixing and blending of those 2 batches. It will go into the outloading bin. If we're bagging it, it will then go into one of our site shunters. So there'll be mixing as that malt drops into the site shunter. It will then go down to the bagging hall. It will go into the conveyors and elevators, into another storage bin, and then into the bag. So there is reasonably good mixing. But still, it's a calculated analysis from those individual batches. So there will be some variation between what this calculated C of A blend analysis will be and potentially what the actual analysis of that malt will be. But plus also you need to factor in the analytical error associated with the method. So if you take, for example, moisture. So you'll have a specification for moisture. It may be 3.5%. The typical error associated with moisture is 0.2. So if we're looking to hit a specification of 3.5%, we could analyse that malt 10 times, and because of that error of 0.2, the analytical range of that will be 3.3 to 3.7. So within that 3.5, you will maybe have some malt that could be 3.3 and some could be 3.7, but the blend will be 3.5.
Yeah.
And that's just down to the analytical error, and that would be the same for all the parameters.
Yeah, it's really interesting. Maybe it goes to back to something someone told me once. It's malt is best to analyze how it reflects in the brew house, because of all there's so many. It's such a dynamic thing. I think it's such a really good analogy Jamie made as well, is that malt just doesn't mix like liquid. So we always, whenever a brewer is thinking about blending or they're like, oh yeah, of course it's quite easy, put one in the other, but it's actually really difficult to get all of those grains to be homogeneous. So I totally understand. A question I just thought of actually is, over time, would the parameters change if you were to reanalyze? So
they can do. I mean, we've done there's a lot of research that has been done into the how malt analysis changes over time. One of the things that can happen is moisture pickup. It's a hygroscopic product, so you've dried it down, and it can pick up moisture. So you can see some changes. One of the big ones that is maybe interesting to brewers is that we analyse it. So it comes off kiln, we analyse it. Typically, for the typical maltings, we'll send it up to Berwick-upon-Tweed for the central lab to analyse it. So it'll be analysed within sort of 12 to 24 hours of it coming off kiln. But what you have to imagine, that malt has come fresh off kiln, so all of the moisture that sits within that grain is concentrated in the centre of that grain. And over time, that moisture will then equilibrate around the grain. And that changes the way that grain will process. So things like friability can vary, because the moisture distribution within the grain can have an effect on the way it mills. And I know there's this sort of lot of kind of anecdotal information about malt that's fresh off kiln can have slightly different filtration characteristics. So fresh off kiln can be sort of filter slightly.
Do we have? I think we've got a couple of customers that won't that have to have a time space between kilning and then accepting it to the brewery. It actually has a sort of rest period.
Yeah. Some customers have a 2-week rest period for them.
Because it becomes more homogenised within the grain.
Yeah.
Not just within the whole lot, within the grain as well, which is quite crazy.
And that's really cool.
Yeah, I know one Mura who make the mash filters, they had done some research a while ago looking at the filtration sort of properties of fresh and aged malt, and they did show that sort of fresh malt doesn't filter as well as aged malt, and that sort of comes back down onto the sort of the idea that customers have built in 2 weeks of rest period for malt. So there will be certain characteristics that will change. Coming back to moisture, that's one, but a lot of the characteristics won't change over time, or not significantly. But there is one caveat that I would perhaps put on that, which is milled.
Well, yes, and also how the brewer then stores it at their place as well,
absolutely,
whether it's going to pick up moisture, become slack, too hot, things like that. I was going to go back just briefly about the consistency of a load, say. So because of the way we're moving the grain around and mixing it, when it goes onto the back of the vehicle to a big brewery, then it's going to get tipped through their conveyor system. That whole batch is going to be homogenised. So that whole batch will perform the same in the brewery. The only problem you've got in a silo is if you put that on top of another bit of load in there, it doesn't come through one after the other. It comes through the middle of the silo.
Yes.
So you can't really count it. So you're going to have to almost count just past where you thought the grain you had in there already. But allow for a bit of mixing, and then you'll get a picture of what you've got. And then the next one will go on top, and then you'll get that little mixed point as well. And again, for bagging, everything that goes down to the bagging hall on that bagging run will be homogenised. So if you're buying 1 pallet a week, you're better buying 4 pallets of the same run, because it will perform for those 4 weeks in exactly the same way.
Yeah.
And we do have some a customer who was taking crystal malt, and we realised, I think it was probably about 20 tonnes a year, it was better for them to take it in 2 big dollops of 10 dollars. Tranche?
It's a great word,
Yeah,
dollar.
dollars.
Really is a motive, isn't it? It really makes you...
That's a professional maltster's term.
Dollar. Of 10 tonnes, because every single bag of malt in that 10 tonnes was exactly the same. We checked the colour right across it. It was completely the same. Whereas taking every now and again you see a colour variation in this beer. Because when you're on a crystal medium or 150 old money, there's still variability in that crystal within the spec and also within the analysis of it.
So, yeah, I mean, I think that's been really interesting, especially for me. As I said, when we first had these calls, there was a lot of information. I was like, yeah, that's really useful to know. I think one of the big takeaways for anyone listening is looking at the degree of modification as an overall picture, not on just looking one, maybe even two parameters, I think, and understanding that a malt COA is the sum of all parts. It's not just individual measurements or analysis that you can look at. You kind of have to, as you said, like build a picture or create the story of the malt. I thought it was really interesting to know.
It's three-dimensional, if that makes sense.
Yeah, you should do 3D malt COAs.
There's some extra special Excel.
I've just got one last question for you both. So Jamie's been really excited to answer. So Jamie and Dan, I'm going to put you both in. I was going to do you individually, but I felt bad. I'll put you in together. What do you think makes a great brewer?
Well, I'm just going to say whatever Henry Kirk said, because I agreed with that. But also, you didn't hear that, okay. I think they need to be a jack of all trades, master of none. They need to be able to communicate across all the different skills involved in brewing. So you need to talk to your maltster, you need to be a chemist, you need to be a biochemist, a microbiologist, you need to be an accountant, you need to be a chemical engineer, mechanical engineer. But at least be able to have the conversation, and then pull your expert in when you need them.
Mm-hmm.
And I mean, a lot of brewers, and I know where my limits are. I assure you, they're not that far from me.
Yeah.
Yeah. But I've always tried to surround myself with a big network.
Yeah.
I'm not a great brewer. I'm just saying that's what great brewers
Yeah.
do. If I was a great brewer.
That's what I would do if I was one. Yeah.
I think it's still brewing. Yeah. I'm just good about. I talk a good game.
Dan?
You're looking at me now. Yeah. Everything that Jamie just said.
Yeah. I mean, your suppliers are your experts, specifically. And yeah, I think when you work in a big brewery, you've got lots of people around you. There was always someone around you who had a bit of knowledge on something. And if you're on your own in a brewery, you should be looking outside of your brewery and bringing people and consider those suppliers as your team members. Yeah. I always thought that was really important.
Yeah.
And I think that's...
But you could give them jobs. You say, I really need to know this information. And they'll go off and do it because that's their job.
It sounds so easy, but often I think people become quite insecure and they think they have to know everything. They have to be experts in every single field. I know what that pain feels like. I definitely went through that when I was like, I must know everything.
Yeah.
And then it gets to the point, and it is basically insecurity because you don't feel like you know everything, so you feel like you have to. But it's exactly, I really agree. It makes great brewers understanding that.
I think sort of coming back on that point, the best, if you come back to sort of what makes a good brewer, I think the good brewer is the brewer that can have a conversation with their suppliers. The best relationships that I think I have are those where we have a sort of an open, honest discussion with yourselves, and we can sort of say, well, what are you seeing in the brew house? Because you as the brewer will come back and say, well, we're seeing this problem, filtration issue, but that's the sum total of the information we get back, and it's kind of like, well, but what is it? Is it slow filtration? Is it sort of like you're not getting the same extract? What is it? We're open to having those conversations, and we're not your enemy. We like to have those conversations because, believe it or not, we actually want the malt to work for you. We don't want to just sort of supply something that's not going to work. That our role is to give something that you can use and produce good beer from.
Yeah, I mean, sometimes you'll go into a brewery and then they'll tell you about a problem they're having with the malt because you've gone to the brewery. And they could have just told you.
Yeah.
And you think, we could have saved a lot of time there, because we could have done something to help.
Well, you guys must have listened to episode 9 of the Modern Brewer podcast where it's called Know Your Suppliers, because that was the exact same answer as Andrew Patterson, who said...
Oh, it was Andrew, well, not Henry, sorry.
Andrew Patterson, who said... he said, knowing the suppliers is what makes a great brewer.
And I was a supplier to Andrew when he was a brewer. He was Dark's, that wasn't he?
Yes.
Yeah. And he was a good brewer, a customer, because he wanted to have a conversation with you when you went in. And you could he would ask you specific questions about the things that I knew about. And I could support him that way. And that's he was a good brewer.
It was a good beer.
Good beer,
Yeah, good beer. That was a good beer.
All right, well, look, I just want to say a big thank you to you both. It's been a good amount of time, and I know it's everyone's got busy days, so I really appreciate it, and I know that hopefully the listeners will have got a good amount of value from this. So thank you for so much for coming on the show, and we won't be able to go to the pub now because it's past lunch, so
We've missed out on the
so we're just going to go like wither away. But
Yeah.
thank you so much for coming on the pod, and it's been a pleasure.
Yeah, cheers.
Cheers. Thank you very much.
Well, that concludes the mini-series on malt. I really hope you enjoyed all 3 episodes. I really appreciate the feedback. And if you have any further comments or feedback or criticisms of the episodes, please do let me know via the usual channels. I'm always active on LinkedIn. That's where you'll probably best find me. Also on Instagram. My LinkedIn is Chris Lewington. And my Instagram is Chris__Brewington. Something I never really thought I was going to have to read out on a podcast when I originally made it. Please, if you want to never miss another episode of the Modern Brewer Podcast, hit that follower, hit that subscribe button, and you will not miss the next episode, which is going to be with Adam Johnson from Murphy's, all about how brewing aids and treatments can help your process, what you're doing wrong, and how you can improve it. Thank you so much, and I'll catch you on the next episode of the Modern Brewer Podcast.